Welcome to this version Foster film. We want to talk about the unit circle, especially for calculus students. We're really focusing on the radian ring around the unit circle and the radical coordinates. Not so concerned about the degree ring, as degrees are never utilized in the calc class. Let's start right away. So I know the unit circle is a circle with a radius of 1, and what's important for you to realize first of all is that if it is laid on top of an XY coordinate grid, these four ordered pairs are real easy to see. Moreover, I have to know with radians that the circumference of the unit circle, or the distance around the unit circle, the formula for circumference is 2 times pi times radius. Well, I've got a radius of 1. This makes the circumference of the unit circle equal to 2 pi. Now this red line here is kind of the start line for the unit circle, and when I go around the unit circle I go in a counterclockwise direction, and as we've stated here, we start at 0 radians and the finish line is 2 pi radians. So the next thing I'm going to do is cut this thing up. If I'm just going to cut up 2 pi into fractions and take care of these 45-degree increments all the way around the unit circle. Most students are strong with these with regard to radian measure. So if all the way around is 2 pi, I know that halfway around is pi. I know that half of pi is pi over 2, half of pi. And down here, this is 1.5 pi, also known as 3 pi over 2. Further have a quarter of pi, 3/4 of pi. This is pi and 1/4, 5 pi over 4. And this is 7 pi over 4, or essentially 1 3/4 pi. So no sweat here. I've cruised around the unit circle and just taken 2 pi and cut those pieces of pizza up and taken appropriate fractions. Pretty simple story. The difficulty a lot of students have is the leftover radians here, and I'm hoping to show you kind of an easy way so that you'll never get these wrong. So I'm going to start right with a concept called the sixth sense. Kind of like that movie, The Sixth Sense, you know, where that kid sees dead people. So it's kind of an old school movie. Maybe you've heard of it. If you haven't, you got to gain a sixth sense here. Cruising around the unit circle, it's as simple as you cruise around here in these 30-degree bumps, just start counting pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, all the way around the unit circle. And when you have one that needs reducing, reduce it. So I know this first 30-degree increment is pi over 6. The second one is 2 pi over 6. Reduce it by cutting them both in half. That's pi over 3. Then 3 pi over 6 coincides with pi over 2. Here comes 4 pi over 6, but I got to reduce it. Cut them both in half. 2 pi over 3. 5 pi over 6. 6 pi over 6 is equal to pi. Here comes 7 pi over 6. 8 pi over 6 needs reducing. Cut them both in half into 4 pi over 3. 9 pi over 6 is right there. 10 pi over 6, cut them both in half, is 5 pi over 3. This is 11 pi over 6. And yes, it's true, 12 pi over 6 is equal to 2 pi. So you've got every single radian measure. Again, what do? I know all the way around is 2 pi. Then I cut this thing up into 45-degree increments. I have all these red outputs that you're looking at. Then I use the sixth sense and go these 30-degree increments and just start counting. Pi over 6, 2 pi over 6, 3 pi over 6, giddy up. Just make sure you reduce every fraction that can be reduced, and you'll be sitting in butter. So there is the radian ring. All right, so next, let's talk about these coordinates associated with the unit circle. So every point on the unit circle can be plotted. Like this red dot you're looking at, from the origin, you got to go a specific amount right and a specific amount up to reach that point. Well, you see the symmetry here, how the distance right and the distance up will be the same. Most students know that this one is equal to root 2 over 2, comma, root 2 over 2. How about this one? So here's a little trick of the trade. This is where students botch the unit circle sometimes. Here is my advice. I like to do what I call go fishing. I'm going fishing right down to the x-axis, drop a fishing line straight down, put an X marks a spot there. Do you see that X? That means something to me because it is dead in the center between 0 and 1. Well, the number dead in the center between 0 and 1 is 1/2. That's how I know that the ordered pair associated with this point is the ordered pair 1/2, comma, √3/2. After you have that one, you guys, this one, you just swap that last ordered pair up and get √3/2, comma, 1/2. All right, so no memorization trick or something. Just go fishing down the x-axis and know full well that that x coordinate up there is 1/2, and you know the one that's tagged along with that is √3/2. Most students, you know, they know the √2/2s and the √3/2s. What they can't figure out sometimes is what goes where. So there's a little trick of the trade. Hopefully that helps you remember. So right here is, of course, 0, 1. And over here, you know, at this stage, I'm really just reflecting the ordered pairs from the first quadrant. And I've got the symmetry, the same distance left as up. Makes no surprise to me that I'm negative √2/2, comma, √2/2. This guy up here, I can go fishing if I'd like, but I know that's negative 1/2, comma, √3/2. This one's got to be negative positive now, negative √3/2, comma, 1/2. There's negative 1, 0. Do you know which one I'm going to do next? Yeah, that one with pretty symmetry right there. It's going to be negative, negative. Take a look. What's coming now? I got to go fishing. I got to toss my fishing line upward. But you can see clearly I'm going to get negative 1/2, negative √3/2, making this guy negative √3/2, comma, negative 1/2. Did you guys catch that mistake before I made it? I didn't catch it. All right, so keeping cruising. You know that 0, negative 1 makes perfect sense to everyone. Symmetry here, √2/2, comma, negative √2/2. Fishing here, 1/2, comma, negative √3/2. Swap it up here, √3/2, negative 1/2. I'm going too fast, rewind. So now, I've got the radian ring, I've got the radical coordinate ring. My question is, yeah, how is that stuff linked with sine, cosine, and tangent? So here's the skinny. What I want to give you two real quick examples. So every coordinate around the unit circle, I have an x and a y coordinate. Those correspond to cosine and sine. My memory trick here is just to remember they're alphabetized. Cosine comes before sine. So I know every x is a cosine and every y is a sine. That may be a little confusing as a standalone. Let me give you an example. So now I'm challenged to find the sine of pi over 6. The sine of pi over 6. I locate pi over 6 on the unit circle. Ding! I think about what is the ordered pair associated with radian pi over 6. I believe it's √3/2, comma, 1/2. Ding! I'm looking for the sine of pi over 6. Therefore, I want to steal the y coordinate. Y always corresponds with sine. So I know the sine of pi over 6 is equal to 1/2. So I know the sine of pi over 6 is equal to 1/2. You can convince yourself further, making sure you're in radian mode on your calculator and actually calculate and evaluate the sine of pi over 6. You'll get 0.5, I promise. Okay? One more example. This is the cosine of 4 pi over 3. Oh gosh, 4 pi over 3. I don't know where 4 pi over 3 is. Yeah, you do. Sixth sense. This 4 pi over 3 comes from 8 pi over 6. Go ahead. See if you can find 8 pi over 6 on that unit circle before I show you where it is. Pi over 6, 2 pi over 6, 3 pi over 6. You got it? Here it is. 4 pi over 3 is right there. I'm going to go fishing straight up there, realizing that the ordered pair associated with 4 pi over 3 is negative 1/2, comma, negative √3/2. And if that's the case, and I want the cosine, do I steal from that ordered pair the x coordinate or the y coordinate? Since it's cosine, and cosine comes before sine alphabetically, I know I want to steal the x coordinate. the cosine of 4 pi over 3 equals negative 1/2. The cosine of 4 pi over 3 equals negative 1/2. Okay, so there's just two examples. I don't want to get too trafficked up here. I will just add this one comment. If you're ever asked for tangent, you have to take the sine divided by the cosine. So you have to take the ordered pair and take the sine value and divide it by the cosine value to arrive at the tangent value. Not often will you see that on the AP exam, for example, but not beyond the AP exam to give you a scenario like that. So there's a unit circle in a nutshell. Hopefully that's helpful. And feel free to take a second glance at that. But I would encourage this. Go ahead and get a blank unit circle in front of you. Kick out that radian ring and radical coordinate ring and test yourself with regard to some sine and cosine action and see if you can land that plane. Unit circle made easy. Over and out.